Hello friends, welcome back to this session. So we are solving the miscellaneous exercise 5B. So in the last video we have seen the first 5 questions of this miscellaneous exercise. Now in this exercise or in this video we will be dealing with the next set of 5 questions. Okay, so the question number 6 is like this. Question number 6 goes like this. Prove by vector method. Prove by vector method that a quadrilateral is a square, that a quadrilateral is a square if and only if IFF diagonals are congruent, diagonals are congruent and bisect each other at right angles, at right angles. Okay, see, it's very important to understand this question statement. Okay, and I know this topic is little bit lengthy, or you can say it's a boring, but if you are okay with the concept, so it requires hardly 5 minutes to prove these statements. Okay, so don't feel like these topics are very boring. These are important, though these are the boring. This is very important because this may directly come as the theorem in your exam. Okay, so descriptive type में ये सब आ सकते हैं भाई. So don't think that कि this बहुत difficult है, बहुत boring है. नहीं, if your concepts are okay ना, no problem, you can solve these statements easily. So क्या बोल रहा है, just move step by step, follow these steps. Means what, whenever you read this statement you try to get the figure from the statement. क्या बोल रहा है कि भाई approve by vector method that the quadrilateral is a square. तो square निकालो एक. So suppose we have this square. Okay, yes, A B C D, let's name this as a B C D, A B C and D. This is a square. So quadrilateral is a square if and only if its diagonals are congruent. Okay, so first diagonal निकालो. So AC is one diagonal and DB is another diagonal, congruent and bisect each other at right angles. Bisect each other at right angle means what they want now. This is what 90 degree and these two are same and these two are same. Okay, now we will see how we can prove this. So this is what the bisection point is. So let's name this point as a P. Okay, so for this question or for this statement we have to prove three things. Number one, that is the AC and BD or DB are bisecting each other at point P, at P. That we have to bisect. मतलब क्या है, P should be the midpoint of AC and DB. Next thing you have to prove that this AC is perpendicular to DB, because see at right angles बोला है ना, so AC is perpendicular to DC. And the third thing is what you have to, the diagonals are congruent. Means what, your length of AC is equals to the length of BD or DB as far as the scalar quantities are concerned. So these three things we want to prove here. Okay, so using this scalar quantity we can easily prove this, but उन्होंने बोला है कि वेक्टर मेथड से प्रूव करना है. So how we can proceed? Okay, see here, given is what we are considering, the ABCD is a square. So ABCD is a square. Okay, so in that square what you can say, AB bar, see this is what AB bar is equals to DC bar. What you have is AB bar is equals to DC bar. Okay, so if I write down in the vector form, so this will be equals to B bar minus A bar equals to C bar minus D bar. Okay, so implies if I divide on both side by 2, what I will get is, so first I will take these negative parts on the opposite side. So b bar plus d bar equals to c bar plus a bar. Okay, so after this, if I divide on both side by 2, what I will get? B bar plus d bar by 2, it is equals to a bar plus c bar by 2. Okay, so this is nothing but what? It is a midpoint formula. Midpoint formula for BD and AC. See here, for BD and AC, these 2 points, these two midpoints are same and they are meeting at some point P. So this is what the position vector of a point P, which is B bar plus D bar by 2 or A bar plus C bar by 2. As these BD and AC are sharing the same midpoint, what you can say, they are bisecting each other. Okay, so first one is proved, they are bisecting each other. Next we want to show that AC and DC are same, sorry, AC and DC are perpendicular to each other. So let's find out the AC bar. Okay, so using the triangle law, what will be this AC bar? AC bar is equals to what? It is AB bar plus BC bar. Okay, let me write down there. So AC bar is equals to AB bar plus BC bar. This is what we have is AC bar. Okay, now what about the DB bar? Sorry, what about the DB bar? AC perpendicular to DC ne, AC should be perpendicular to DB. Okay, now what I want is AC bar. Now I want a BD bar. So let's take this BD bar here. So BD bar is equals to what? So this is BC bar plus CD bar. Okay, so BD bar, so similarly what we can have is BD bar is equals to BC bar plus CD bar. Yes or no? Plus CD bar. But what is given, as it is a square, what you can say is AB bar is equals to DC bar. Okay, so I will write down this BC bar minus DC bar. Okay, now I want to prove these two AC and BD are perpendicular to each other. Then what should be the case? Concept क्या बोलता है? If you have the dot product of this AC and BD, it should be equals to 0. Let's check. So this is nothing but AB bar plus BC bar dot BC bar minus DC bar. Okay, now let's open the bracket. So AB bar dot BC bar, so AB bar dot BC bar minus AB bar dot DC bar, okay, plus BC bar dot BC bar minus BC bar dot DC bar. Okay, so what can be cancelled out? Do we have any cancellation here? See here, what we have, AB is equals to DC. So let's substitute AB is equals to DC. So AB bar dot BC bar plus, sorry, minus AB bar dot DC bar is nothing but AB bar. So let's substitute, plus BC bar dot BC bar minus BC bar dot DC bar is nothing but AB bar. Yes, this is AB bar. So what can be cancelled out? See here, the first part is AB dot BC and this is a BC dot AB. Okay, dot product commutative law is applicable. Now what we have is, see, BC bar AB bar square minus this is nothing but AB bar square plus this is BC bar square. Okay, so AB bar minus BC bar कितना आ गया boss? You are already saying कि भाई AB and BC are same because this is what this square, this is a square we have. Okay, so in this square all the sides are equal. AB is equals to BC. So what you can say here, the square of AB bar minus square of BC bar is equals to 0. So this is 0. As AB and BC are sides of same square, okay, therefore their length will be same. So what you are getting, AC bar dot BD bar, it is equals to 0. Means what? AC and BD are perpendicular to each other. Okay, very good. Now let's see, दो हो गए भाई, देखो आपने क्या क्या हो गया, फर्स्ट पार्ट हो गया एंड सेकेंड पार्ट हो गया. नाउ वी वांट टू प्रूव दैट AC is equals to DB. Okay, so for that purpose let's take simple third concept, which is, let's take, they are asking for the length, so we'll have AC bar dot AC bar, AC bar dot AC bar. So AC can be written as what? So from the figure, if you see, what is AC? AC is nothing but, see here, this AC is nothing but AB plus BC, AB plus BC. Okay, so let's have that. It is a AB bar plus BC bar dot AB bar plus BC bar. Okay, this is what we have. Now if you open this, what you will get? Open करो इसको. This is equals to AB bar dot AB bar, AB bar dot AB bar plus AB bar dot BC bar plus BC bar dot AB bar plus BC bar dot BC bar. Okay, and this is equals to AB bar dot BC bar. See here, AB bar dot AB bar becomes AB square, of course AB square, and this BC bar dot BC bar becomes BC square. Okay, now see here, AB bar dot BC bar is what? AB bar dot BC bar. See, these two are what? Perpendicular to each other, then their dot product should be equals to what? 0. Okay, so this part becomes 0 and this part becomes 0 because they are perpendicular to each other, and we know that if they are perpendicular, that dot product is equals to 0. So ये कितना गया बॉस? AC bar dot AC bar कितना गया? This is equals to AB bar square plus BC bar square. Okay, magnitude of AB square and magnitude of BC square. Okay, very good. Now similarly you can prove for this BD. Okay, similarly you can prove for this BD. BD is what? It is a BC dot CD. Okay, let's take the same example. So BD bar dot BD bar, it is equals to, it is a BC bar plus CD bar plus, sorry, not plus, it should be dot product of BC bar plus CD bar. Now open the brackets, so you will be having BC bar dot BC bar plus BC bar dot CD bar plus CD bar dot, it should be dot BC bar plus CD bar dot CD bar. This is equals to, now again these two are perpendicular to each other, so we can directly make them 0. Okay, so what is remaining is mod of BC bar square plus 0 plus 0 plus mod of CD bar square. Okay, now if you consider this equation number 1 and equation number 2, and somewhere we have proved that as it is a square, we have AB is equals to DC. Okay, all the sides are same now, so AB is equals to DC. See here, we have AB, BC and BC both are same. Here I have the AB bar, mod of AB square and mod of CD square, which is nothing but the sides of the same, what? Side of the same square. So we can definitely say that AB is equals to CD. If AB is equals to CD, AB square and CD square also be same. Okay, therefore what you are getting is BD dot BD, it is equals to BC square plus, you can either write down CD square or AB square, no problem. Okay, so it is, let's take CD only, CD square. Okay, now this is equals to equation number 2. Now from 1 and 2, from 1 and 2, what you can say is AC square, it is equals to BD square. So in this way we have proved that the length of AC and the length of BD are same. Hence the third part is also proved. Okay, so remember that. अगर ये एक क्वेश्चन आपको समझ में आया ना, तो आपके सब कंसेप्ट आपके क्लियर होने वाले. So make sure that you are understanding this question. Okay, perfect. Now let's see the next one. Question number 7. So what it says? Question number 7. Okay. If ABC is a triangle whose orthocenter is P if ABC is a triangle whose ortho center is P and the circumcenter is Q, and the circumcenter is Q, then prove that PA bar plus PB bar plus PC bar, it is equals to 2PQ bar. Okay, so for this question you require our previous video where I have told you the concept of triangle centers, so circumcenter, orthocenter, incenter, on the centroid, and I have given one more very important concept, that is a Euler's line. Okay, so if you have seen that video, then only you can solve this question, otherwise no, it will be very difficult. Now let's see. So let's have one small triangle here. Okay, so if you are not seen, please go and check out that video. So this is what we have, ABC, and in the Euler's line I have already told you, if you plot all the the centers of a triangle, what you will have is, you will have first orthocenter, okay, then you will have centroid, and then you will have the circumcenter. Okay, so this is what we have, OCC, orthocenter, centroid, okay, and the circumcenter. This is orthocenter, centroid, and the circumcenter. This is what the Euler's line is. Okay, so please make sure that you have seen that video. अभी क्या बोला in this question, P is a orthocenter, so let's name this as a P. P is orthocenter and Q is the circumcenter, so this part becomes Q. Q becomes the circumcenter. Okay, so now let's have some nomenclature here. So let A bar, B bar, C bar, A bar, B bar, C bar, and Q bar be the position vectors of point A, B, C and Q with respect to P. Okay, with respect to P मतलब क्या है, PA bar हो गया अपना A bar, see this PA bar, okay, this PA bar हो गया A bar, then we have PB bar is equals to B bar, PC bar is equals to C bar, and PQ bar is equals to हो गया Q bar. Okay, this is what the position vector of points with respect to P. Now let's have some small construction here which will be helpful for us to solve this question. Suppose this is a point D we have, and this point D is a middle point to the segment BC, and you know that if it is midpoint, so what we can have is D bar is equals to B bar plus C bar by 2, which will give me 2D bar, it is equals to B bar plus C bar. Okay, now this D bar is also the position vector of point D with respect to P. Okay, so these are the prerequisite for this. Now using the concept from the last video of the centers of a triangle, I can easily write down that AP bar, okay, using Euler's line concept, what I can write is AP bar is parallel to QD bar. Okay, all these vectors are parallel, so if you have not seen that video, please go and check out. So this is AP bar is parallel to the QD bar, they are parallel to each other and they are vector multiple of each other also. And what is the relation between their lengths is AP is always equals to 2 times of QD. Okay, AP is always the 2 times of QD. So if I convert into vectors, so what I will get, AP bar is equals to 2 times of QD bar. So if I open this will be equals to AP bar मतलब क्या हो गया, minus of A bar हो गया, because what we have considered is PA bar is A bar. Okay, see this is PA bar is equals to A bar, so it should be AP bar will be minus of A bar. So this will be minus of A bar, which is equals to 2 times of D bar minus Q bar. Okay, so let me open this bracket. So minus of A bar is equals to 2 D bar minus of Q bar. So if I take Q bar this side and A bar that side, so 2 D bar is what? Just now we have proved 2 D bar is equals to B bar plus C bar. Okay, so this is B bar plus C bar, B bar plus C bar and plus A bar. Okay, so 2 D bar is B bar plus C bar plus A bar. So okay, so this is equals to what? See, A bar, B bar and C bar are nothing but the vectors PA, PB and PC, and what is Q bar is nothing but it is a PQ bar. So this is equals to, okay, we missed here 2, so this is 2 Q bar, so this will be 2 Q bar. So and if I replace these vectors by their original vector, so this will be equals to 2 PQ bar, it is equals to PB bar plus PC bar plus PA bar. Okay, so these are the vectors with respect to P and A. So hence proved. So this is only thing we want to prove, that is PA plus PB plus PC is equals to 2PQ. See here, this part we wanted to prove. So for this question what you require is the concept of the Euler's line. Okay, and you should know the relationship between this AP and DQ. Okay, so this AP and DQ. Okay, so if this AP is 2, this will become 1. Okay, in that way. Very good. Okay, so I hope you have understood this question. Now let's start the question number 8. Okay, next question. So let me have the space here. Question number 8. What it says? If P is a orthocenter and Q is the circumcenter. See, again same concepts we are having here. Orthocenter, circumcenter, incenter and centroid. So that's why I have made a separate video on that. So if P is orthocenter, Q is circumcenter, and G is centroid, okay, of a triangle ABC, of course, then prove that QP bar it is equals to 3 times of QG bar. Okay, let's start this. Now you know the definitions of this orthocenter, circumcenter and the centroid. Okay, and I have already told you how this centroid divides the segment orthocenter and circumcenter. So if this is a orthocenter O, this is centroid and this is a circumcenter. Okay, then what we have the case is it is always divides in the ratio 2:1, which this centroid part always divides the segment O circumcenter in the ratio 2:1. So we will make use of that. So this C bar, so sorry, this is what, this is centroid, so it will be G bar. This is point is given as a P and this point is given as a Q. So G bar is always equals to what you have, 2 Q bar plus 1 P bar divided by 2 plus 1 using the internal section formula. Okay, let's solve this. So this becomes 3 G bar, it is equals to 2 Q bar plus P bar. Okay, so if you open this, what I will get is it should be P bar minus Q bar, it is equals to 3 G bar minus 3 Q bar. Okay, ये वाला ऐसा part मिलना चाहिए. So what we don't have here is I have here 3 Q bar. Okay, so let's add 1 Q this side and this Q on this side. So it is add Q bar on both sides. So this will be Q bar. So plus Q bar, it is equals to 2 Q bar plus Q bar plus P bar. So what I have done here is I have added 1 Q bar. So this will give me the 3 G bar plus Q bar. और क्या हो गया? So this will be Q bar equals to 2 plus 1 is 3, so 3 q bar plus p bar. Okay, now let's take this q on this side and this q on this side, so this will be 3g bar minus 3q bar, it is equals to p minus q, p bar minus q bar. ये क्या हो गया फिर, 3 कॉमन लिया तो it will be g bar minus q bar and this will be p bar minus q bar, and this becomes what, 3 into qg bar and this becomes qp bar. Okay, this is the only thing we want to prove. I hope it is. So qp and 3qg, see here, qp and 3g, qp bar is equals to, see this, qp bar is equals to 3qg bar, so qp bar is equals to 3qg bar, hence proved. It's very simple. Okay, so for that purpose what you require this concept. What is that? The centroid divides the segment PQ in the ratio 2:1. Always remember that. Okay, good. Now let's see the next question. Question number 9. Let me have the space here. So the statement like this. Question number 9. P and Q are midpoints of the sides AB and CD. P and Q are midpoints of sides AB and CD of quadrilateral ABCD respectively, of quadrilateral ABCD respectively. Okay, no problem. If R and S are midpoints of diagonal, if R and S are midpoints of diagonal AC and BD respectively, AC and BD respectively, then prove that okay, क्या प्रूव करना है, PQRS is a parallelogram by vector method. Prove that PQRS is a parallelogram using vector method. Okay, using vector method. See, the question seems to be very difficult. Okay, बहुत लेंदी रहेगा. No, this is not the case. ठीक है, let's try to prove this. Okay, so what is first step is, भाई फिगर निकालो अपना पहला. Okay, so this will be the case here. What they are saying, P Q are the midpoints of the AB and CD quadrilateral. So first draw one quadrilateral here. ये हो गया first quadrilateral. Okay, means what, opposite sides length same होना चाहिए. Okay, ये ऐसा हो गया. So let's name this. So this is A with position vector A bar, B with B bar, C with C bar and D with D bar. Okay, now let's have the diagonals also. R and S are the midpoints of the diagonal AC and BD. So diagonal बोला है, so this is what our AC diagonal and this will be a DB diagonal. Perfect. Okay, now let's have the small PQRS, so which is like this. So ये हो गया बड़ा ABCD quadrilateral. Now let's have PQRS. P and Q are the midpoints of AB and CD. So P, here will have P, this is point P with position vector P bar. Okay, then we have Q bar which is the CD का midpoint है. So this is what the Q bar. So Q with Q bar. R and S are the midpoints of AC and BD. So R is midpoint of AC. So this is what we have, midpoint R with position vector of R bar. And S, he is here somewhere. So S with S bar. Okay. Now if you join these 4 points, so what you should get? If I join this line and this, so this PQRS is what? The parallelogram. This we have to prove. Parallelogram means what? the opposite vertex should be same, ये and ये same होना चाहिए, this part is equals to this part, so their direction as well as their length should be same. This we have to prove. Okay, so for that purpose how we will proceed? Okay, see here, as they are the midpoints, so first of all let's find out the position vector of all the points. Okay, so P is what? It is the midpoint of AB, so this becomes A bar plus B bar by 2. Q bar is the midpoint of DC, so it becomes D bar plus C bar by 2. R bar is the midpoint of AC, so it becomes A bar plus C bar by 2. And we have finally S bar is equals to B bar plus D bar by 2. Perfect. So what we want to prove is that QR bar is equals to SP bar. Okay, this we want to prove. So how to prove? So let's take one by one. What is QR bar? QR bar is nothing but R bar minus Q bar. Let's substitute their values. R is what? It is A bar plus C bar by 2 minus Q is what? It is a D bar plus C bar by 2, which is equals to, if I open, I take 1 by 2 common, so I will have A bar plus C bar minus D bar plus, sorry, it should be minus C bar, okay, plus C bar minus C bar cancel. So what is remaining? This is equals to 1 by 2 A bar minus D bar, okay. So ये हो गया अपना QR bar. Now let's solve for the SP bar. ये हो गया अपना QR bar, equation number 1. Let's solve for the SP bar. So SP bar, this is equals to P bar minus S bar, which is equals to, what is P is? It is A plus B by 2 P, and S is what? It is B plus D by 2. A plus B and B plus D. It is A bar plus B bar by 2 minus B bar plus D bar by 2. Okay, so if I take 1 by 2 common on both sides, what I will get is 1 by 2 into A bar plus B bar minus B bar minus D bar. So B bar cancel. So what is remaining is 1 by 2 A bar minus D bar. Oh, what is this then? So this is what we have the same. So from equation number 1 and 2, what you can say? Their RHS are same. So we can definitely equate their LHS also. So from this we can prove that QR is equals to SP. So from 1 and 2, that is QR bar is equals to SP bar. QR bar is equals to SP bar. Similarly we can prove for this also. एक बार QR and SP हो गया, तो next time क्या करोगे आप? Prove. Okay, prove क्या करना है? QS bar is equals to RP bar. Okay, so if you are able to prove this, then of course we have proved that this PSQR is the parallelogram. Opposite side should be the direction as well as the length should be the same. So similarly we can prove that QS is equals to RP. Okay, so similarly we can prove that QS bar is equals to RP bar. Okay, so it is equals to RP bar. Therefore PSQR is a parallelogram. Okay, is a parallelogram. Of course PQRS is a parallelogram. I hope it is clear everyone. Okay, good. Now let's see the next one. Question number 10. Okay, so what is the statement here is? Okay, yes. So question number 10 statement is like this. Very important. Okay, please note this as a 5 star. कितना हो गया 4 and this is 1 is a 5. Okay, very important. Show that the line segment joining the midpoints, very simple and very important. Show that the line segment show that the line segment joining the midpoints of two sides of a triangle of two sides of a triangle is a parallel to third side is a parallel to third side and the length of and half the length of the third side. Okay, okay. So seems confusing, but it is of course not, because we will move step by step. What is our first step is draw the figure. Okay, we'll have one small triangle, so triangle ABC. Okay, let me have a good triangle here. So this is what a good triangle is. Okay, A, B and C. We have triangle. Show that the line segment joining the midpoints of the two sides of a triangle. Suppose AB and BC are the two sides of a triangle, and these are the M and N are the midpoints of these two, and the line segment we are having is MN. This MN is parallel to BC, and it is the half the length of, that is MN, length of MN is equals to half of the length of BC. This we have to prove. Okay, if somehow you've proved this, and if I convert into vector form, what you can see here is M bar is the scalar multiple of BC bar, and we have already seen that the first theorem of this topic says that if the vectors are the scalar multiple of each other, then they are collinear vectors or the parallel vectors. Okay, so this is what we have to prove here. Now let's see how we can prove this. First of all, let's find out the M bar and N bar. So M bar is what? It is the midpoint of AB bar, so it will becomes A bar plus B bar by 2. And what is N bar? It is nothing but A bar plus C bar by 2. Let's find out Mn bar. Mn bar is equals to N bar minus M bar. It is equals to, what is N bar is A bar C by 2 minus A bar plus B bar by 2 equals to A bar 1 by 2 common, so it is A bar plus C bar minus A bar minus B bar divided by 2 वो तो हम ले लिया है, so this is equals to A bar cancel out, so this is equals to 1 by 2. What is remaining is C bar minus B bar, so this is equals to 1 by 2 BC bar. So this is nothing but Mn bar. That's it. This is the only thing we wanted to prove here is, see what Mn bar is scalar multiple of BC bar, and you know that if we have the scalar multiplicity, then the Mn and the BC are parallel to each other. Mn bar is parallel to BC bar. Okay, so BC bar, and because the reason is what? Because scalar multiple theorem, scalar multiple vectors. Okay, that's why. And if I take magnitudes on both sides, what you will get? Mn bar mod of Mn bar is equals to 1 by 2 of mod of BC bar. Means what? Whatever the length of BC, अगर उसका half किया तो मुझे Mn मिलने वाला है. The same thing we wanted to prove here is that, see here, half the length of the third side, and it is parallel to the third side. Okay, so not only for this triangle, you can take any triangle. Okay, so you can have this triangle here. So if I take these two sides, so it is same. So if I have the third point, midpoint of this, so if I draw this line should be parallel to this AB, and it should be the, suppose this is a P, so Pn should be half of the AB. Okay, so this is very important theorem in a triangle we have. Okay, I hope you have understood everything here. So with this we will conclude this miscellaneous exercise. We have seen n number of questions from part A and part B. Okay, so please go through all these questions one by one, try to solve on your own. See, only looking at these questions is not at all sufficient. You have to have a practice for all these questions. Okay, take out all the notes on a single page, that will be better for you. Write down all the concepts, internal section क्या रहता है, external section क्या रहता है, and little bit of this geometry part is bit tricky. So for that, what I recommend is write down the concepts whichever I have told you during these theory classes. Okay, and also understanding that centers of triangle is also very important, because most of the questions come from that part. Euler's line, centroid, circumcircle, okay, orthocenter, median क्या रहता है, altitude क्या रहता है, those parts also we have to be very clear. Okay, so I hope you have understood everything here. Okay, so with this we will conclude this topic here, and in the next class we will see the brand new topic. Okay, so till then, bye bye, take care.